This is Algebra Lesson 1-2, Order of Operations and Evaluating Expressions. A power. A power is the base and the exponent of an expression in the form of a to the n power. For example, 3 to the 5th power is considered to be a power. 3 to the 5th. That's the whole expression itself is called a power. The exponent is a number that shows the repeated multiplication. So in the power of 3 to the 5th, the 5 is the exponent. The base is the number that is multiplied repeatedly. So in the 3 to the 5th, the 3 is the base. That means we're going to take 3 and multiply it by itself 5 times. So it looks like that. To simplify, you replace an expression with its simplest name or form. So literally, 3 to the 5th, we could simplify that by actually multiplying out what actually 3 to the 5th is. 3 to the 5th, which would be 3 times 3 times 3 times 3 times 3. Well, 3 times 3 times 3 is 27, and 3 times 3 is 9, and 27 times 9 is 243. So 3 to the 5th is the same thing as 243. 243 would be the simplest form because of the fact that we understand 243 a little bit better than we understand 3 to the 5th. Evaluate means you're going to substitute a given number for a variable and then simplify it. And we'll go into that a little bit later in this lesson so you'll understand what to evaluate means. All right, to simplify powers, what is the simplified form of each expression? To simplify each expression, you're simply going to apply the exponent the way that they ask you to. So 10 to the 5th literally means we're going to take 10 and use it as a base 5 times. So we have 10 times 10 times 10 times 10 times 10. And I don't know about you, but there's an easy way to remember how to multiply powers of 10. We just write a 10, okay, and we write a 1 essentially, and we have to make sure that there are 5 zeros because it has an exponent of 5. So 10 to the 5th is 100,000, because 10 times 10 is 100, 10 times 10 is 100, and 100 times 100 is 1,000, and 1,000 times 100 is 100,000. So 10 to the 5th is 100,000. 3 to the 4th means 3 times 3 times 3 times 3. Well, 3 times 3 is 9, and 3 times 3 is 9, and 9 times 9 is 81. So 3 to the 4th is 81. 2/3 to the 3rd power means 2/3 times 2/3 times 2/3. And you'll notice I use different ways of showing multiplication. I use the dot a lot of times and the parentheses a lot of times. I rarely use the x as a multiplication symbol because it's often used as a variable instead. Now, if you remember with multiplying fractions, you multiply straight across the top. 2 times 2 is 4, 4 times 2 is 8. And you multiply straight across the bottom. 3 times 3 is 9, 9 times 3 is 27. So 2/3 to the 3rd power is 8/27. From here, we can move to understanding a little bit more about what we're going to be doing here. It says, in order for mathematics to be universally understood, okay, because it's a worldwide language. It's one of the few things that students, no matter what they've brought up with, whatever their nationality is, whatever language they were born speaking. For example, if they were Chinese, or if they were Italian, or they were German, or they were from Switzerland. Doesn't matter if they speak Swiss, or they speak Spanish, or they speak Italian, or they speak German, or they speak Mandarin or Cantonese. Mathematics is what we consider to be a universal language. So they follow a specific order of operations, and this is really, really important. If they didn't follow a specific order of operations, then it would be really, really hard for people to be able to solve problems, because we would do things differently. And then that could be really bad because of the fact that science and health sciences are universal. When somebody builds a telescope, They don't keep that information to themselves. They share it universally. When we have a problem, for example, the COVID-19 vaccine, all of that information was shared universally. Different countries were sharing what they knew how to find a COVID vaccine with all the other countries because it was important that everybody got this vaccine, not just that the United States got the vaccine or just China got the vaccine or just Japan got the vaccine. Everybody needed the vaccine. So the doctors worked together, the scientists worked together, and in order to work together, they have to be able to talk to each other. So the more complicated the problem is, the more important it is to follow the proper order of operations. Now, you've probably heard of the phrase, please excuse my dear Aunt Sally, which is a great phrase for learning and understanding the order of operations as long as you understand some really important things. P is pretty easy. P means parentheses, otherwise known as any type of grouping symbol. That would be a bracket, a brace, or a parenthesis. Sometimes also a fraction bar is a grouping symbol. And then the next thing you need to do is follow the exponents. Anything with exponents needs to be taken care of. We start to get into trouble when people get into the multiplication, division, and addition and subtraction because they start to believe that multiplication always comes first before division, and it doesn't. It's multiplication or division from left to right as you are reading whichever comes first. So if a division part of the problem comes first, you will do that before the multiplication. It's whichever one comes first as you read a problem from left to right. Same thing happens with addition and subtraction. You do addition and subtraction next, and you'll either add or you'll subtract in order in which comes first from left to right. That's why that little important thing is in red here. Multiplication does not necessarily come before division or addition before subtraction. You simply do either multiplication or division before you do addition and subtraction from left to right. So let's look at a few problems so that we can make sure we are understanding how to do these. So I'm going to extend my page here. Let's take a look at a few of these. And it's really, really good to show what you're doing. And it's always good in mathematics to show what you're doing vertically down the page versus horizontally across the page. Because as problems get more complex, it's much, much harder to follow them horizontally than it is vertically. If I look at problem number 1 here, it says 2 plus 5 times 3. My order of operations says I need to do any grouping first. Parentheses, we don't have any. Then we have to do exponents. Don't have any of those either. Then multiplication or division. Well, I do have some multiplication, and that would be right here. So I'm going to write down my 2 because I'm not doing anything with that. I'm going to write down my plus sign because I'm not doing anything with that. But I am going to take care of the 5 times 3, which is 15. So my second step becomes 2 plus 15, and then I simply answer that by saying, oh, 2 plus 15 is 17. Down the page vertically is neat and tidy, and it shows people that you know what you're doing, and it shows me that this is the process in which you're doing something. Okay, let's take a look at this problem. 3 times 6 minus 4 squared divided by 2. Okay, there are no grouping symbols, no parentheses whatsoever. But there are exponents, so I have to take care of my exponents. So I'm going to leave my 3 times 6, and I'm going to leave my subtraction. But 4 squared is 4 times 4, which is not 8. It's not 4 times 2. It's 4 times 4, which is 16, and then divided by 2. So now I'm going to look at this and go, okay, what do I need to do next? Well, I have a multiplication here, and I have a division here. Since the multiplication comes first from left to right, I will do it first. So 6 times 3 is 18. Leave my subtraction sign, and then 16 divided by 2 is 8. So now I have 18 divided by, actually subtracted by 8, okay? And 18 minus 8 is 10. I look at problem number 3 here. I have 5 to the third plus 90 divided by 10. So I have to do my 5 to the third first, which is 5 times 5 times 5 plus 90 divided by 10. Well, 5 times 5 times 5, that is 5 times 5 is 25. 25 times 5 is 125 plus 90 divided by 10. And some people would say, well, Mrs. Sheeline, why can't I do most of this in my head and only show down a couple of things? You really need to show all your steps because you can mess up your thinking if you try to do too much in your head and not write things down. It's really easy to get numbers reversed. So it's just a good idea to just write things down. Now I'm looking at this and I'm like, well, I can't do anything with the 125. I can't do anything with the plus sign, but I do need to do the 90 divided by 10. And 90 divided by 10 is 9. So then I take 125 and I add 9 to that, and I get 134. And notice how I always box or circle my final answer so I know you're done. It's important for me as a math teacher to know when you've arrived at your final answer. Okay, most of the time I'm going to be looking at your papers and you're not going to be around, so I can't point to something and say, is this your final answer? So you need to tell me that it's your final answer by boxing it or circling it or doing something that obviously sets it aside from everything else. Now, if you look at number 4, you might say, well, there's no grouping symbols on number 4, but there actually is. This division bar acts as a grouping symbol, which means I need to do the entire top first, the entire bottom second, and then I need to divide them. Okay? This grouping symbol means basically do 4 plus 3 to the 4th, and then do 7 minus 2, and then divide them. Okay, so basically that tells me I need to do 4 plus 3 times 3 times 3 times 3, and I'm going to do 7 minus 2 underneath it. Well, 3 times 3 is 9, so if this is 9, and this is 9, 9 times 9 is 81, so this becomes 4 plus 81 over 7 minus 2, which happens to be 5. 4 plus 81 is 85, divided by 5, and that happens to be 17. And I'm done. And if you want to, you can put little equal signs in front of each step. I've had people do that before. That doesn't bother me. I tend not to do that because it's just extra work that I can tend to make a mistake on, and so I tend to try not to do that. I don't like to make mistakes. I'm good at them, but I'd rather not make too many of them. All right, when you simplify an expression with parentheses, you need to work from the inside out. Okay? Innermost parentheses to outermost parentheses. And then make sure you follow the proper order of operations. So in these particular problems, they have quite a few parentheses, quite a few grouping symbols. If you look at number 1, it has both brackets and it has parentheses. Okay? Just in case you didn't know, this little symbol that I can never draw, that's a brace. This is a bracket. Not that it really matters. They could be backwards for some people. It's fine. They all mean multiplication. They always mean whatever's inside there you do first, and anything on the outside of that, if there's no addition or subtraction symbol, it means multiplication. So in this first problem, I have 4, and then a bracket, parenthesis 2 times 9, end the parenthesis, plus parenthesis 15 divided by 3, end parenthesis squared, and then the end of my bracket. So I need to show quite a few different things here, and it's probably going to take me several steps. So the first thing I'm going to do is I'm going to do a 4, keep my bracket, but 2 times 9 is 18, so I'm going to keep that. And once I've done what's in the parenthesis goes away. So I've taken care of what's inside of the 2 times 9 parenthesis because it comes first from left to right in my parentheses. Okay, and then I'm going to do plus, and then I'm going to do 15 divided by 3. I'm going to do that first because it says do what's in the parenthesis before you square it. So I have to work inside of the parentheses, outside of the parentheses. So I'm going to do what's inside that parenthesis first, which in this case, 15 divided by 3 is 5. So I have a 5, and then I have to square it. Then I end my bracket. Okay, so now order of operations says I still need to do what's inside those grouping symbols, but I have to follow the order of operations within those grouping symbols. So I have a 4, I have a bracket, I have an 18, but I have to take care of this 5 squared. 5 squared is 5 times 5, which is 25. Now I can look at this and go, 18 plus 25. 18 plus 25, I can add those together, is 43. Okay, and I still have that bracket because the bracket next to a number with no addition and subtraction symbol means I'm going to multiply that together. So I basically have 4 times 43. And at this point in time, if you want to write it as 4 times 43 with parentheses, that's perfectly fine. It means the same thing. And we just multiply that out, and that's going to be 172. And again, I will box my final answer. Notice how I worked vertically down the page, step by step. If you show me your steps, I can normally figure out where you went wrong if you have an incorrect answer. So the more work you show me, the more I can figure out where you've gone wrong if you have the incorrect answer. Let's look at number 2 here. If I look at number 2, I have 2 sets of parentheses, so I'll work from left to right. So I'll do this one first. So I still have a 3 here. I'm still going to have a parenthesis, even though because of the fact that there's no plus or minus sign between the 3 and the 8, there's only a parenthesis. I have to keep the parentheses after I've taken care of what I've done inside of them, because that means multiplication. So 8 plus 6 is 14. And we're going to divide that by, well, we got to do this. 4 squared first is 16 minus 10. So I'm going to keep my 3 times 14 divided by 16 minus 10 is 6. Okay, so now I'm just going to do my multiplication first because it comes first from left to right, not because it comes first before division. It's just it came, as I read from left to right, 3 times 14 comes first. So this comes first, that's 42 divided by 6, and 42 divided by 6 is 7. Okay, if you follow the proper order of operations, we'll all get the same answer. If we all followed whatever order of operations we wanted, we could have a bunch of different answers here. And unfortunately, in the world of healthcare, it would be really bad if you were figuring out how much medication people were supposed to be taking and you did it the wrong way and you over-medicated them or under-medicated them. Hence why mathematics has to have a universal way to work with it so that people don't mess up and kill someone. All right, when two or more variables or a number and a variable are written together, treat them as if they were written in parentheses. So for example, 4xy is equivalent to parentheses 4xy end parentheses, and xy squared is equivalent to parentheses xy squared quantity end parentheses. To evaluate, you replace each variable with a given number, then simplify using the order of operations. Here's why I said that we would get back to what it means to evaluate something. Evaluating something means to substitute in a given number and then work out the order of operations. So here it says evaluate each expression for c equaling 2 and d equaling 5. Okay, so here I have 4 times c. So every time I see a c, I have to replace it with a 2. Every time I see a d, I have to replace it with a 5. Well, I'm not going to write 4, 2. Because 4c means 4 times c, so I have to have 4 parentheses times 2. Otherwise, it would look like 42, which would be totally different in this problem. Minus 2 times d, d is 5, divided by c, which is 2. So there we replaced all our variables. D was 5, and c was 2, and we've replaced them all. Now we just follow the order of operations. So there are no grouping symbols, so we're going to do multiplication and division from left to right, whichever one comes first. So 4 times 2 is 8, minus 2 times 5 is 10, divided by 2. Now, we have 8 minus 10 divided by 2. Order of operations says we should do this 10 divided by 2 first, because we do division before we do addition and subtraction. So we have 8 minus 10 divided by 2 is 5, and 8 minus 5 is 3. Almost ran out of room here. Number 2. If I substitute in, d is 5, so I have 5 plus 6 times 2 divided by 4. Keep the 5 because there's nothing I can do with that right now. Keep the plus sign. 6 times 2 is 12 divided by 4. Then the order of operations says I should do this division, so I'm going to have 5 plus 12 divided by 4 is 3, and 5 plus 3 is 8. Okay. Do pay attention to the fact that it is going to get really important later on that you understand how to put something in when you're evaluating something taken to an exponent. Okay, so in this problem number 3, I'm going to have 40 minus d happens to be 5, but I'm going to put it in parentheses like this because every time you put something in and you need to take it to an exponent, you always need to put it in parentheses. If it's positive, it's not going to change anything, but if it's negative, it could. So it's really important to remember to always put it in parentheses and with the exponent on the outside of the parentheses when you're substituting something in and evaluating it. Okay, so I have 40 minus 5 squared plus c happens to be 2, d happens to be 5, and we're going to multiply that by 3. So order of operations, keep the 40. Keep the subtraction. 5 squared is 25. Plus 2 times 5 is 10, 10 times 3 is 30. So we did the exponent and then we did all the multiplication. Okay, 40 minus 25. Let's see, 40 minus 25 would be 15. So I have 15 plus 30, which is 45. All right, evaluate for x equaling 11 and z equaling 16. So x is 11 times 16, and then we're going to put it in a parenthesis, and then we're going to square it, which is massively different than problem number 2. Problem number 1 says we're going to take x times z and then square it. So we're going to take 11 times 16. Okay? 11 times 16 is 176. 176, and then we're going to square that. So 176 times 176. I am going to use my calculator on this. I could do it by hand, but I'm going to use my tools that I have. And that ends up to be 30,976. So there we go. All right, number 2 says x times z squared. So x is 11 times 16 squared. So here we're going to take 16 and square it first. I just happen to know that 16 squared is 256 because I know my square root's pretty good. So this is 256. So then 11 times 256 is 2,816. Notice the difference in the answers. Just because of where that square ended up, whether that was x times z and then took that quantity and squared it, or we just took z and squared it and then multiplied it by 11. All right, it says, what is an expression for the spending money you have left after depositing 1/4 of your wages in savings? Evaluate the expression for weekly wages of $40, $60, $80, and $100. Okay, so what you have to do here is, this is what we consider another real world expression or another real world problem, something that you would see outside of the classroom. If you get paid a certain amount of money every week and you are going to put 1/4 of your money in wages, you're going to have 3/4 of your money left, right? So if you put 1/4 in savings, that means you have 3/4 left to use as you want. And in this case, that's our spending money. So we're supposed to evaluate the expression for the spending money we have left. If my weekly wages was $40, how much spending money would I have left? If my weekly wages was $60, well, how much spending money would I have left? If my weekly wages were $80 and then weekly wages were $100. So first of all, I have to write an expression. Okay, so I'm going to say that I'm going to let W equal my weekly wages. So my expression that I'm going to have left, what I have to spend is I'm going to have 3/4 of my weekly wages. So 3/4 times W. So if I make $40, I will have 3/4 times 40. And if you remember, you can cross multiply in mathematics. I can say that, oh, look, 4 goes in itself once, it goes in 40 10 times. That means 3 times 10, I will have $30 to spend if I make $40. Okay. If I make $60 a week, I will have 3/4 of 60, which means 4 goes into 60 because I know 2 goes into all of those. 4 goes into 60 15 times, I believe. Yep. And then 3 times 15 is $45. If I do 3/4 of 80, 4 goes into 80 20 times, and 20 times 3 is 60. Means I would have $60 of spending money. And if I did 3/4 of 100, I 4, whoops, I did not do what I wanted it to do. Four goes into 125 times, and 25 times 3 is $75. So I will have $75 of spending money. So if it says evaluate the expression for weekly wages of 40, 60, 80, and 100, okay, so here's my expression, 3/4 W, and I would have $30, $45, $60, or $75, depending upon how much money I had earned each week in wages. Okay, so my expression is 3/4 W, And my evaluation of that would be $30, $45, $60, and $75. All right, your question for today. Answer the following question at the end of your notes. Why is it important that everyone follows the same order of operations?